Hello again everyone, we're going to be continuing with our nuclear radiation stuff today, having a wee look at the activity of radioactive sources, looking at how we can measure that and how we can do some calculations involving that. So first of all, what is the term activity? What does that mean when we're talking about nuclear radiation? Well, the activity of a radioactive source is just the number of nuclear decays that take place every second within that source. So remember we had our different types of decay, we had alpha, beta and gamma. This just basically tells us how many times per second one of those decays takes place. And when the decay happens, these particles, alpha, beta or gamma, they are emitted from the nucleus of the atom. And we can calculate this activity by using the following equation. So that's just A equals N over T, where A is this thing called activity. It's measured in a unit called becquerels, which is just got the symbol capital B small q. N is just the number of decays, and T is the time in seconds. So a typical question you might get, something like this that says, a radioactive source decays 96 million times in 1 minute. What is its activity? Well, we know our formula here is A equals N over T. We know that the number of decays, shown here, is 96 million. Our time is 1 minute, so we have to convert that into seconds. There are obviously 60 seconds in a minute, so we just sub those in, pop that number into our calculator, and we get that the activity is 1,600,000 becquerels, or 1.6 mega becquerels. Remember that capital M, that is just mega, which means times 10 to the power 6. So obviously we do want to detect radioactivity. We can't see it, we can't smell it, doesn't make sound, so we have to find a way to detect it, and that is done using a Geiger-Müller tube connected to a rate meter. So you might have seen this in movies and in TV shows and stuff where they take the detector around and it makes these audible clicks from a loudspeaker. That is it counting these decays as they happen. So the Geiger-Müller tube, you point at your source, it registers every decay, and you can do that over a period of time, and that will give you your activity. One thing just to watch with this is that this is not exactly the same as the total activity, because what you're measuring here is just in one dimension, one direction to that atom. These decays are random and pushed out in random directions, but they are proportional to each other, so this gives you a good idea about the activity of that source. And as we saw previously, we have radiation all around us all the time, this background radiation. So when we're measuring the activity of a radioactive source, we have to take that into account. So the first thing we have to do is actually measure what the background radiation is for about a minute using no source at all. We just register those clicks over a minute, and that tells us the activity of the background radiation. We can then pop our source in, and then using that, we get another measure of counts, which will have changed. If we subtract the background count from that source count, that'll give us the corrected counts in 1 minute, and then we can calculate the activity using that formula that we've already seen, A equals N over T. So that's a quick overview about the activity of radioactive sources. I'll leave you guys to get on with some of the problems and try this for yourself.